I am back. It is time to deal with Sprite. I'm actually a little interested that didn't like blow up in some terrible way. Not in some terrible way, in some good way. Let me take a look at my code. Maybe I can make it do that. I may have been a little inconsistent about how I did that. I just ignored a bunch of these. I really shouldn't have done that. Okay. So now I've got to figure out. Because what we're doing, let me see if I can. I don't have it open because I keep closing my window, even though I shouldn't. Um, Player sprite is red. We're setting that. Quadruple the sprite size. This is one. This is like one thing that we're not dealing with. So this is X5, I believe. Yeah. So that's like in the middle of this. No, that's not 5. What is that? That's 4 plus 2 plus 7. That's 7. This is like right in this ignore for now sort of setup. Yeah, actually, I think the way to get around that, I think everything's sort of in that range. This might not be quite true. Is to so this is rsync. There's a good message about this. There's other things on the vblank pin. That's fine. We're gonna get rid of that. Um, this whole range is ignored. That's the one piece we know that we should be getting an error for. Not cargo test, cargo run. Don't need the debugger. There we go. Don't close the window because I want that buffer open for when I need it. Oh, I remember why I did this. Oh, that's right. That's super annoying. Um, right. Uh, Basically the initialization that's really standard for Atari games is that as soon as the system's turned on, they just like loop through everything in zero page and set it to 0. Um, which includes like all the registers in the TIA and like right, it's not zero page, but all and like all the memory and stuff. So basically, if I didn't handle this, I couldn't get past initial or do this. I couldn't get past initialization. So we're gonna have to go one at a time, which is fine. So like for instance, I know that 7 is one that we need to deal with, right? So if I do that, then I should. Nope, I still need to get past initialization, right? So I just may need to handle it. Bummer. Um, and what is 7? I love that. Uh, it's like sprite size. Let's see if I can find what. These are reads, right? No, these are write registers. Huh. Am I wrong about the sprite size? Am I wrong about how you write 7 in binary? I don't think so. but I might be wrong that was a 7, right? 4 plus 2 plus 1. How does that work? Oh, right. I'm loading a value, not the address 7. I'm loading the value 7 and putting it into NU size 0. So NU size 0 is address 4. So it's the top of this. So that makes sense. Okay, so that's going to be a new thing here. Let's hit 5, and then we'll say 0x04. I will just call it what they call it, self dot nu size 0. So it's going to be the first player size, and it's going to be the value. Although I don't know if I want to store the direct value there, because I think we can just translate it on the fly. So let's take a look at what that register looks like. Seven would be so this is 0, 0. So the missile is 1 clock wide, but the so this is 111. So this is quad sized player. So this is okay, yeah. So this is what this register looks like. The top has to do with the width of the missile. So that can either be 1 color clock wide, so like essentially 1 pixel, 2, 4, 8, and uh, so the missile, like each player has a missile and they're colored the same way, and like you can do some kind of crazy stuff by moving those around. But you can think of this as like a lightly generalized like Pong machine, basically. Like there's like it came with paddles. It like there's balls and missiles and or balls and just all kinds of stuff that like is reminiscent of Pong. So if you do 110, then you get 3 copies of the player. Um, you can see what that does. If you do 101, you double the size. If you do 011, you get 3 close copies. That's kind of cool. If you do 100, so you can like sort of control how many copies of things there are. This gets pretty complex, and I'm trying to decide if I want to. This is half a television line. 8 clocks per square. I think I'm just going to handle it as I go. I think I only use the quad size in this game. I think so. The plan is going to be when I'm done with um, my game, because it doesn't use many of the capabilities. There's a bunch of like test ROMs out there that kind of like test one thing at a time, and so I don't think it'll take me too much longer to finish my game. Um, when I get done with that, I will start going through test ROMs until I either get bored or am finished to some extent. I think we can just handle the one case right now. Um, we'll just like make ourselves a function here. I'm not really doing that, am I? I'm like sort of doing everything in line. It's a little different because this could have like multiple values. Yeah, okay. So here's what we'll do. We'll say set player one size. I'll do that with the value. That way we can get a good message if we're when we're done. So lovely. Set eventually this could be generalized, I think. So it's not player one, it could just be player, and that's a parameter based on we'll see this for now. And value, that's a U8. Kind of, nope. Doesn't return anything. Dot. The internal thing will call what it's called in. So this will be like a match. Value. Let's say whatever else. Unimplemented. No, I'll say no. Let's print out a nice little message for that. Actually, we can probably start there and make sure that we're hitting the right thing. Yeah. And then run. Yeah, okay, so we don't know about any size. Let's say this is a we'll just call that make a little enum up here. So there's a couple options, but we only really care about one right now, which is quad. Here. Oh, we need like a none too. Is there a none? Default's going to be like one copy. So we'll just do one copy, standard size, one copy, 3 copies. 2 copies wide, double size, okay. Because we're going to get the value 0 here at some point. What doesn't it like about that? Oh, it just I hadn't saved. Okay, cool. So then we're at some water. Okay, so then we should. We know we're gonna have it set to 0, so let's do. Um, set 0 equals 1 copy. Oh, I'm doing that already. Awesome. Variant's never constructed. Not implemented. No size or number matching 0, 7. So that's exactly what I expected. So for 7, we're going to do quad. And then we still don't have our cursor. So we're still missing a piece of this, which is expected. So if I go to my tic-tac-toe DASM, let's make sure that so Sprite. I may just need to find what the right thing here. Yeah, okay. Register is right. Selection players. Blah. Playfield. I think it's resp 0 is what I want. Reset player 0. Let's take a look at that. So that's definitely part of it. Let's see. I think we're like jumping to these places. Okay. Yeah, so what's going on here is that determine the horizontal position of the cursor. So basically, I'm loading. Have a variable that's player X position, which is in RAM somewhere, and I'm loading that. And if it's comparing it to 0, if it's 0, I go to second position. Otherwise, what goes to third? Okay. Oh, okay. Oh, I see. So I'm actually just sort of jumping through these. So basically, man, it's been long enough since I wrote this that I don't remember. exactly what everything does. But basically, so I'm like storing this variable. Um, I think that it can either be 0, 1, or 2, and that corresponds to left, center, and right. And then resp 0 is like it's called a, I can't remember what it's called, but it's a register that like that you write to, and it basically determines the, like, it doesn't like latch anything, it just like sets an action to happen. And the way this works is that you set it like the scan line before you want to draw it, and the next scan line, that's where it'll start drawing your sprite, right? So basically what's happening here is that, based on which position you're in, it's waiting a certain amount of time. So if you are in position 0 horizontally, then it sleeps for 17, and I've like figured out the math here that puts it in the right place when you flash. I think it's called a flash. When you flash this register, and then it just jumps to the end of the line where we actually wait for 2 lines, which is interesting. And then if it is not equal to 0, we move on and check 1. And if it's not 1, then you just go to the third position. And then if it's not 2, okay, yeah, I covered that case. I didn't need to, though. So that's interesting. So I covered the case where you got here and it's not 2, which is not possible. And then these just all sleep for the like correct amount of time. It gets a little bit longer as you go, so that you're going further across the screen. So let's take a look at the documentation for rest pause 0 and see if we can. Oh, 0. There it is. The horizontal position of each object is set by writing to its associated reset. They're strobe registers, which are all strobe registers. They trigger their function as soon as they are addressed. That causes the object to be positioned wherever the electron beam wasn't sweep across the screen when the register was set. For example, if the electron beam was at 60 color clocks into a scan line when resp 0 is written, player 0 would be positioned 60 color clocks in on the next scan line. And whether or not player 0 is drawn to the screen is a function of the data in the GPO register, which is another thing we're going to have to deal with. Let's see. Relearning this stuff as I go. GRP0. There it is. So we'll have to deal with that too. Which I think we can take a look at. Let's see. These are a little bit more useful. P0. Yeah, it's just, you can also reflect the player. So there's like all sorts of stuff you can do with these things. It's kind of cool. So we'll just so basically I don't think I do any reflecting or anything like that in this case, unless I don't know, we'll see. But basically bit is a number of color clocks wide, depending on what we set earlier. So I do believe we can just set up this strobing, which will be a really interesting problem. TIA. So that was... Doesn't say where that is. Okay, this says where it is. It's at 1.0. It's here. So we'll take this out for now, and then we'll say 0x 1.0. We'll do, this is going to be like RSP0 equals, so we actually know our current color clocks, and we can take a look at here, beam position. So that takes our, not big, how's it going? Thanks for the follow. We are doing some in-depth Atari 2600 emulating here. So yeah, so this tells us exactly where the beam position is. I am like super awesome. Super super skeptical that I got that all right. The timing of this thing is like pretty like finicky. But I'm hoping I did. There's like a thing where like basically I'm worried. I think this is wrong. I know this is wrong. Because this is set before the clocks are done for this. So the way it kind of works in on the Atari 2600 is that like everything's synchronized via like a central clock, and the beam actually moves. The color clocks are synced to be 3 times the clock of the 6507 or 6502. But but basically like the loads that happen on the TIA like happen after the last cycle for the instruction, right? It just kind of like it kind of works out that way. I think it's just like how long it takes everything to propagate. This is like way outside of my like comfort zone getting into hardware stuff. But so I didn't want to like simulate the individual clock cycles. So I basically had like run the instruction and then do stuff and then like increment the clock and then do stuff after that. I think WSync is an example of this. Because WSync shuts down the yeah, WSync like shuts down the CPU, but it has to happen after the clocks are like updated for the CPU, because then it just like it wakes it up at the beginning of the next one. So I'm gonna need to do something similar to this. So I'm gonna say like set resp 0 is true. And I think I'm handling all this locally. So we'll just put all this wsync. We have it like, wait. Um, actions to take after clocks are updated. The wsync falls into that, although it's its own thing. Vblank and vsync don't actually do that, although actually they might. Vblank definitely doesn't. Yeah, you know what? We can just put them all in the same. They kind of do. Although we're ignoring vblank because it just tells the beam to turn off, and we're not drawing it if the beam should be off. So I'm sure that'll come back to bite me in the butt. So set it's p0 false. So then let me make sure that I know what's happening here. We're doing wsync stuff out here. So we can actually do this. So here's what I was talking about. This is where the instructions are executed. Basically the there's a lot of stuff here happening, so they don't have to emulate like individual clock cycles. I really want to avoid just like adding one in a short loop. I think it's like I'm sure it'd be fine. It'd be plenty fast enough. It just made me feel bad. So basically in here, some things are happening that have an effect on the outside world. So in this execute, so when those happen, we're like, there's a case of setting a timer. There's a case of like setting the wsync, and then this and RSP0 and a couple other things will happen here in this sync. So we do the instruction, we like queue those up essentially. Then we do ticks. All our ticks or all of our clocks are like up to the right point, and then we'll just go through and like do the things we need to do to make sure that this all works. So we'll just go to the definition of sync here. So we have this, and we'll need to do this whether or not sync happens. So we'll just go ahead and do it before. So if we won't return here. So if self dot set RSP0, so we're going to do self dot RSP0 equals self dot, and now we can get the color, the beam position, and it'll be up to date. I was going to say we don't have that type, which actually makes sense. We'll need to unset. So the thing is it does lead to like some pretty gnarly, like sort of manually setting and unsetting things. So we don't TIA. I feel like I have player stuff. Yeah. One right. Zero. This is going to be the same as my color. It's going to be U size. It'll be a limited U size, but that beam size will take care of it. Cool. We'll need to set this. This will be 0 by default. Okay, do I have any other issues going on? No diagnostics found. All right, so just to see that that's working properly, I'm gonna have some display output here. So I've got beam position called, let's see, give ourselves a new line. I don't need this combined playfield anymore. We'll do this layer one sprite. So we can see the size of it pretty easily. That is what. Um, and use size 0. Okay. We can actually, for now, show the debug output of that. Right, we're gonna call this size. Let's do. And then we're gonna do our 0 and do just our regular output for that. We don't have anything here to show. So this will be self dot. And then self dot ISP. And it'll probably say I don't have. Actually, it's fine. Apparently, I do have debug for any size. But yeah, okay. So I just automatically did that, which is good. Okay. So then if I come here and do the debug version of it, see a bunch of stuff fly by. But at some point, I should see this. Oh yeah, it's already set to quad. It's a little surprising. I feel like I must have done something wrong there. So for this debug thing, I had to hold down F until it gets back to checking my input, which it's doing now. Should start drawing. Yeah, for some reason my NU size is already set. So in my respirator is set at a weird spot too. Maybe that gets set. Maybe that gets set before I go into intro. No, that definitely should not happen. So I don't go here first. So I'd expect my rest to be PIA. Hmm. So I'll actually set myself a breakpoint and see if I can figure out what might be going on. Player any size. Yeah. So let's see. What does that look like? I think I need my. So quadruple the sprite size. So this is. Oh, okay. This is happening in setup. Okay. Okay, that's what's going on. So that is getting set to the right thing. Um, Interesting. Okay, so that's happening in setup. The flash is just happening to happen whenever it's like loading. So actually, we might be able to see a different that would happen. So that should actually change. So right now it's at 150, which I think was different than the last time. NU size is quad, which is correct because it's set up in initialization. Here, let me. So I would be expecting to see resp get set differently. 126, so it did get set differently. Will it always end up being 126 in the end? I think that's right. I think that would put me somewhere. All right, that's interesting. Color clocks. So it's divisible by 3. Yeah, okay, I think that's right. So then it just comes to, oh, I need to do, what is it? GP. I was looking at it before. GRP0. Okay, so in TI, we'll GRP0 is 1B. So in the TI, we'll do that for 1B, which is somewhere in the middle of here. So we'll just copy this over. And we'll go up to, but not including 1B, and then we'll do 0x1B here. This will be very similar to our playfield stuff, so we can manage that in a minute. And then this will be everything from 1C up to 2C. Exclusive pattern ranges. Okay. Experimental. So we'll do that. And then so we can see like this is how we're doing these playfields. So we should be able to just do self.g. What are we calling this? GRP0. Straight in there. And it says no type. GRP0. And that is 0. And that'll be similar to the playfield. U8. Whoa, really messed that one up. Cool. And so that should be good. So then we're gonna output it again in here. So we'll just do GRP0. I'm actually really curious if I can. I don't know if I can do this in right. Can I say no? It would it's complex, so I wouldn't be able to do it there. This is going to be 0, 8 B. So it'll output in binary, which will help us visualize the graphics, especially if we need debug. And this will be self.grp 0. We'll just make sure that that gets set up. And then it just comes to drawing it. So nothing's loaded in the graphics yet, but it should be coming around. And there it is. So you saw that it was, and you can see every time the beam goes by, it's going super fast right now, but it's drawing all ones for the top it's a square around one of these squares. It's drawing all ones for the top and then ones around the outside and then all ones for the bottom. So that is getting close to something that we can work with. For I in color clocks to new color clocks. Okay. So this is where we are drawing out the play field. Is that right? We're doing some gonna have to mess with colors a little bit. We're gonna have to do some messing with layering. And that's actually adjustable, which is fun. But for now, we're just gonna write over the playfield buffer because it's the background. Okay, so I'm doing some stuff to make my life easier here with the columns and rows and like converting them. But I don't need to do that for the GR drawing columns line. So I still think we're gonna do this within the within this check, which is checking that it's in drawing range. So we're just gonna do. We'll actually label this whole thing playfield draw. Do we need pixel? Where are we using pixel? So we're like kind of. Oh boy, I made a mess for myself here, didn't I? That's fine. So I think it's going to be like considerably easier than the playfield, right? So basically, so if it's regular, oh, this is gonna get complicated as I draw like multiple copies and stuff. That's interesting. I'm not gonna worry about it too much right now. But we'll talk about the case where I have it one across or when I have it four across. If I have it one across, then basically like my self dot ref 0. Maybe we may be able to like interesting. Sorry, I'm trying to remember what I did here. not get too stuck in that. I was thinking like I'm gonna have to grab whatever's in the buffer, only overwrite certain places. I don't actually think that's true. I think I can like limit it to writing only if I don't need to draw the background, which is what this is doing currently, or what the playfield is doing. So if I have rest of 0, let's say it's at 126.7 clocks or something. And this I I don't think that's quite right. So let's see what column. Color clocks per line. Drawing start column. Yeah, I may have gotten myself in a little bit of a bind here, but I could just subtract out the drawing start column from my RSP0. So I think that's what I'll do. So basically I like shifted everything around so that I was going to so I didn't have to worry about the fact that like the beginning of the scan line is like there's some blank. I can show you that. Right at the beginning of the line here, there's some blank. And then it starts drawing. So basically I shifted everything over by, I can never read this when it's not blown up, by 68 clocks. So thing is, if I think I can still use that column. That's really all the only thing I care about is if I'm in a column that I should be drawing a thing and it's a 1, then I draw the color. If it's a 0, I just ignore it. So I should be able to do that pretty easily. So basically, if it's 1 wide, whew, it's been a long day. So my brain is melting as we speak. Let's see if it's 1 wide, and I set it to like 127 or something, or 126 is where rest 0 is. And I want it, so I have my GP GRPO. Let's say that's and that's 8 bits wide. So like, I mean, it's not going to be like an index like this, but if I, so it'd be like color clocks on row minus start. So if that's between 0 and 8 for this situation, then I can just index it by this value. If I'm in the quad drawing, which is like, which then I just have to modify it by 4. So it's between 0 and like 64, and then I'll just like change how I do that. Okay, all right. So I think I'm gonna do it. I think I'm gonna do it quick and dirty here, and then we'll probably want to. It's gonna require some matching, so I'll probably want to extract it eventually. But for now, so we're gonna do match. We'll just ignore everything else other than what we want. So self dot 0. We can just do an if let quad. We'll do something here. not complaining about that. It just doesn't know what that is. I'll add that word to my dictionary so it doesn't keep 0. Okay. What is this going to look like? So we know that the column is offset by something. Drawing start count or drawing start column. So then our like adjusted sprite start is equal to self dot resp 0 minus we'll make this a saturating sub because it's an error if you would if we subtracted more. It could be off to the just make it a wrapping sub. Let's make it a wrap off the thing. It's a 64-bit word to or yeah, so it'll be fine. Drawing start column. That's where our sprite starts, right? So if it starts at 68, if it flashes at 68, then it'll start at 0 in our sort of adjusted column stuff. So basically, so if column is greater than sprite start and is less than or equal to and this will all be parameterized later 8 times 4 in the case of the quad. Ooh, where am I? So then based on where we are, so we're looking at an offset inside the sprite. So that's going to be our column minus our sprite start. And then we're going to do something similar to up here. But we'll just actually draw it inside the thing. So if self.gp r0 and we're gonna shift 1 so if we're at the first one we're gonna shift 1 over by 7. So that'll be 8 minus this is we're going to say that is that offset is divided by 4. This will need some cleanup, but I think I'm getting the idea right. So the offset will go up. With the quad one, it'll be divided by 4. So if this is not equal to 0, then we're going to set self.buffer.0. I think we still have access to that pixel. So this will be the same thing. It'll be pixel stride. I think this will be the exact same code. Stride 3. And then we're just going to, we'll copy from the slice that we just make in line here. That'll be, we're just gonna make it red for now, but we need to implement colors next. So red, green, blue, and alpha. And then no implementation of, I missed a parenthesis here. Consider borrowing it. Can we borrow that immediate value? Yeah, I guess we can. Okay. So I I need to get a casino going for the few of you who are hanging around, whether this will work first try. I would I wouldn't bet on it, but you know. Let's take a look. Oh, something went very wrong. Attempted to shift left with overflow. Oh no. First try is not a success. Okay, so um why would that overflow though? Wait, our offset might be 0. Yeah. Yeah. Is that right? So if it's, yeah. So if it's 0 through 3, then it'll be 0. As soon as it hits 4, it'll be 1. So it'll be shifting over 6. And then like that. Second try. Attempted to subtract with overflow. No, second try. Why would this be? There's no way our offset is greater than. Let's just. Because it shouldn't ever be greater than that. 8 times 4 is 64. 8 times 4 is 32. So it should never be more than 32. 32 divided by 4 is 8. Yeah, let's take a look at this and see what's going on. Did I just do something weird? Because I want it to be 0 at the end. I think I just had something that shouldn't be inclusive. I think this to be less than. But let's make sure and not just poke at it and hope that everything's okay. Sorry, that's the sound I make when oh. Right. So our offset is up to 31. I think it needs to be up to 30. Wait, why is it maximum? It should start at 0, right? No, because it's this. So it should be greater than or equal to. That looks right, but then I'm out of range of a slice somewhere at the buffer 186. Right. So I don't want to do this if we shouldn't be though. Because it should be copying the same thing I am from the play field. Is there some guard that's there that I don't know of? No. Just make sure I have the same thing here. That looks identical. It's like way out of range of the buffer for some reason. But why isn't the say self dot we'll just make a thing here after we have the pixel. Let buffer index, and we'll make it just this value in here. That's not how you copy that stuff. What am I doing wrong here? Yank in. Oh yeah, that's wrong. I must not have the right. I thought I had surround on here. So it's yank 2. So that should. We'll just call this buffer range. We'll call it pixel range. What the value of pixel range is moved there. Uh, maybe there's something wrong with that. Why isn't... So we'll just say like pixel start. Say pixel start plus 3. And then here. Hey, it's blue. And it's in the wrong spot by a little bit. So I'm very surprised it's blue based on this pixel that I'm putting here. I'm also a little surprised by the... Wonder if there's a delay from the... I'll have to think about that. It's green. Why is that happening? That is not how I expected this buffer to be set up, but okay. That's red. Okay. So let's compare that against... We can see that it's like... Let's see that there's like one essentially unit, one pixel over here. Let's compare that against the Stella 2600 emulator, which is which I have to remember the key bindings for. Yeah, okay, that's over by quite a bit. The color red is different, but we can take care of that a little bit later. Actually, I'm curious about something because I was thinking about it before, and I think it might be... Yeah, this like should be over like a number of clock cycles over. So the other thing I wanted to check on, having seen that thing. Okay, so if I do that, okay, the X looks right. Everything else looks right about this. It's just that the placement of the... There might be a delay from when it's written to when it hits. Also, just curious about something. But don't do this offset by 4 thing. I just want to see what it looks like. Okay, that's feel like it should be bigger. Look at Stella. We can actually probably look at them side by side. So one thing is just the size is a little different, which is fine. So if I was to move this whole thing over, actually, let's see if we can get one where we can put an X in the middle. There we go. Okay. Okay, so I feel like we're not too far off. I do think it's interesting that the Stella has like a bunch of stuff, uh, has a bunch of like playfield up top and up bottom, and their aspect ratio is a little different. I'm pretty sure I got that right. But that's something interesting to look at. Okay. Um, so let's mess with this and see if we can get it in the right place. And then like check that with our understanding. Because my thought here is basically that when you like a lot of these things like and I know that I'm gonna have to deal with them eventually, is that when you like write to the thing, write to the TIA, it doesn't happen like instantly. Um, like there's sometimes like some clocks that it takes to get like system clocks that it takes to get into the thing. One of those is for playfield. I think it takes 3. I'm wondering if it's the same. So I'm gonna like make some educated guesses here and see if I can get something that looks a little bit more like what we're expecting. And then I want to go find here. Then I'll go find. So I want to do like beam position. This is in color clocks. Like like is it 3 color clocks? Is it like 1 clock off? That would be an interesting issue. Um, then I can go look in the forums and stuff later. No. So it looks like it might be closer to 3 system clocks off than 3 color clocks off. So this would be like +9. It's not. Interesting. What if I did plus? What if I think it's 2 system clocks? And then this happens, and then I have to go kill it. And that looks almost exactly right. So why is there an offset of 2 system clocks? Let's yeah, let's get rid of that. What time is it? It might be time for me to call it quits, but streaming for 2.5 hours. If the electron beam was 60 color clocks on the scanner when it was written. So what I'm in on the next. Okay. This is a nice little guide, but it doesn't have everything. So let's see. Well, if this doesn't come out up immediately, then I will go look a little later. So there's like uh there's a 2 to 3 cycle delay for play fields. Okay. This is what I was thinking, and it looks like it might be one whole machine cycle. Okay, so I think I may need to go look this up a little bit later. I can actually look at one more thing before I go. I see I've lost a bunch of people anyway. Um, so it's probably time to head on. But I can take a look at one thing. Uh, go to we can see where we're expecting this to be. Because we know that when we wake up from async, or wsync, um, we are at the beginning of the line. So it's like I said, it's like 68 color clocks. Does that make sense? That's not even right, is it? No, is that right? Interesting. I'll have to look into that. It is 68, but that's not a multiple of 3. So that's interesting. Um, but if it was 69, then it would be 76 machine cycles. So what's 160 divided by 3 is 80. Um, no, divide by that doesn't even divide by 3 evenly. So there's some overlap into here for machine. Okay, so that I don't think that matters. I just thought these were linked up a little better, but they're not. So, um, so let's see how far we think we are. When we do how far do we think we are when we do PIA resp 0 resp 0. Okay, so for the furthest left position, we think that we are 5, 7, uh, if we're equal, if we're not equal, we're actually 8 clocks in. Compare one is 2 clocks in, or 10. Then BNE, so we're not going to take that branch. So we're 12 plus 27 is 39 plus 3. So 42 times 3. For some reason, my mind can't do that. 126. So we think we're 126 clock cycles in. So 126, 126 minus 68 means there should be 58 pixels in. We can take a look at our 58 of 160. Interesting. Okay. So we can take a look at our run. We can take a look at our debug output. We should see our rest 156. Is that what I... Oh, well, that's just what we started off with. Right. I need to wait until we go through the whole loop again. That's fine. Okay. At some point we should 132. Right, because I added... So it would have been... Yeah, 126, which is what I just calculated. Because I'm at 12 plus 27, 39 plus 3. 39 plus 3. 42. And 42 times 3 is 126. That should put me at column 58. Yeah, okay, so I'm not going to sit here and do this forever. I'm finding, it's interesting that I'm finding that I have to add a little extra, and I'm not finding that anywhere online. That may be enough impetus for me to look through the Stella source code, although I really don't want to do that too much. Or maybe post somewhere to figure out what that is. But so from experimentation, what I'm finding, at least for that middle one, I have to see if it works everywhere. Yeah, I might need some better debugging sort of tools, like graphical debugging tools. But we have this. So it's looking for that. Oh, this is an old version. I have an old version of my rest 0. Have to add 6 clock cycles. So to do figure out why I have to add 6 clock cycles to the position to get it in the right place. Can't find anything easily online about a delay. I think the very last thing I can do is I can think about just do a little bit of math. So 126 plus 126 plus 8. So it's 8 wide. So it's actually 4 times 4 wide. So 16. It's 142. 142 minus 68 puts us at basically pixel 70. I'm trying to find the middle. 74. So 160 minus or divided by 2 is 80, of course. So that actually puts me 6 off the middle. So I have done something wrong with my timing. Interesting. Okay, I'll have to look into that. Because I am surprised. Like that timing adds up, but on the Stella it shows it at the wrong spot. Okay, okay, that will take some investigation. All right, so basically what we did today is we managed to figure out how to get an illegal opcode. We also got our player one sprite on the playfield. And then I think the next thing to do, I'll go investigate this stuff offline. The next thing to do will be to get real colors in here. These are hard coded. But I might do that off screen because it's just a map of like a single register to like a specific color output. It's not particularly interesting. So the next thing to do will be to do joystick input up, down, left, right. I think once that's done, once I can move around, then I will have implemented everything I need for this game. And so then I'll be on to new, exciting stuff. I'm really surprised that Stella. It's like I lost 6 color clocks or 2 counts somewhere. That's so wild. Okay. It's probably my W sync timing. Okay. Well, I'm gonna go look for somebody to raid and see what is going on in other parts of Twitch. I'm gonna drink a beer and let's see. See if anybody's out there doing Rust tonight. Learning Rust with Lumberjack Chapter 9. This guy is dressed like a lumberjack. I think that's pretty cool. Somebody's doing front end WebAssembly, but he's a Spanish language. All right, this guy's English language. So we'll go see what he's up to. He's got 23 viewers, finite singularity. Cool.